right, we are live. You see, I got the tie on today, got buttoned all the way up, shaved a little bit, going clean for test day. Gotta look my best when I get wrecked by this test, if you know what I mean. So let's see. Basically, I'm on day 12 of teaching myself linear algebra from scratch. Never learned linear algebra before. I know up to linear algebra decently, but I haven't learned this, and I'm only using ChatGPT and a little bit of Claude, a little bit of Grok to help teach me this material. I had it design me a curriculum, and now I just finished Unit 2, which means I'm halfway through and I have a test. This test is supposed to take an hour. I'm going to scroll up here to my curriculum that ChatGPT Deep Research designed for me. And you'll see that we are now at this point here. There's checkpoint quiz number 4. So I should actually ask it to start with that. I like to highlight it. And then there's a little quote here. This checkpoint quiz. This will be my warm-up for the test. This is kind of a nice advantage, actually, that I get to take a warm-up quiz. I presume some of the test questions will be somewhat similar. So this will be good. Give me this checkpoint quiz. You don't have to get too fancy with a lot of these prompts. Just do the thing, and it should know from the context. And notice I pull in each lesson, I quote it, because if I just said go to lesson 12 or whatever, I don't trust the AI to remember it. It's got a lot of context. Just look at how long this chat is. It's this is all of my linear algebra curriculum here. And look, I'm not even halfway, and I'm scrolling pretty fast. So there's a lot of context here. I'm only using the 4.0 model because that's what deep research works with. Occasionally, I'll switch to O3 mini high or O1. I find those to be helpful too, but overall, this has been getting the job done. And then when I cross-check it occasionally with Claude or even with Gemini I tried the other day, it seems to still work okay. Seems like I'm more or less on track. So I have my iPad here on the right side of my screen. I'm going to write down, this is first the checkpoint quiz. All right. So question 1, let the set W equals the x vector. W is a set where the x vector is contained. I should ask it just to translate these long equation lines because I don't know exactly what each symbol should mean. The x vector is in three-dimensional space, and x1 plus x2 plus x3 equals 3. Is W a subspace of R3? Okay, so I got 1A. And I'm going to do the same thing I did last time where I actually have ChatGPT grade my test. I found that pretty helpful. Basically, I just send the screenshots, I airdrop the screenshots from my iPad and say grade this, and they give really good feedback. They were a little bit of an easy grader, so I'm going to ask them to be a slightly tougher grader this time, I think. But let's see here. I'm a little afraid to see what it does if I ask it to be a tougher grader, actually, but let's see. They might just take points off because I told them to be tough, even if I get it right, but it'll be interesting to see. This is all about experimenting. You know, if I really wanted to learn the linear algebra, well, this is a pretty efficient way, but I would probably also have some experts. There's a lot of people who pointed out, people saying things like, dude, just get a textbook. Bro, you know, where are the experts in AI or the experts in linear algebra to check if you're actually doing it right? That's all good, but I'm sort of in this post-expert world right now. And if there's one thing I'm an expert on, it's learning. I've been working in the industry for 15 years of academic coaching, executive function coaching, read a lot on learning science. I didn't formally study it, but people pay me good money in order to help their kids learn. So I think I have some expertise there. I am developing it for sure with this class. This is really helping me become a better learner. But the whole question of what is an expert, what is expertise, becomes a lot more pressing now. But I would love if there are any linear algebra professors or if there are any AI experts who are watching this. And I'm specifically, I guess, looking for credentialed people in this case for the naysayers. Like, tune in. I'd love to have you on a stream, on a video, collaborate, and see if this experiment of having AI teach me linear algebra is working as well as I think it is or not. So anyways, is W a subspace of R3? So I'm just remembering a subspace has to be linearly independent, the zero vector has to exist. So zero vector, oh, sorry, it's through origin is what I mean. Through origin, check. 0 plus 0 plus 0 equals 0. That's for x1, x2, x3. And then I go addition. I think this is a check as well. So addition check, because if I have, yeah, I can already see this, but if I go like x1 plus y1 plus x2 plus y2 plus x3 plus y3 equals 0 is the same thing as saying that I'm basically combining these two equations and they're both true. So, and then scalar multiplication, check. So yes. Rank nullity theorem application. How many are there on this checkpoint? Okay, good. Only 4 questions. Because I don't want to spend too much time on this. I have an hour today. The test is supposed to take an hour. This is supposed to take 20 minutes. I talk fast. I move fast. I want this to go fast. So hopefully it takes less than the full hour. Rank nullity theorem application. A is 3 rows by 5 columns. Suppose the rank of A is 2. The dimension of the null space is 3. Oh, whoops. I totally skipped 1B. 1B. I'm not sure if they want me to write out a full proof for 1A, but let's see. I'm just moving quickly here. If it's on the test, maybe I'll write out the full proof. Find a basis for W. Okay. The dimension of W. I'm trying to remember how to find the basis of W. I'm just going to guess and write 0, 0, 0. How many pivot columns does... Oh, sorry. I keep looking at what I'm highlighting. This is what I'm doing. What is the dimension of W? So I need to find the rank and null space of W, I think. I think what I'd actually do here is I say like x1 equals negative and then I'd say that x2 equals, so it might actually end up being different here. I don't think it's this 0, 0, 0. I'm going to actually erase this. All right. Excuse me. Excuse me. Wow. All right. So I'm going to say that x3 equals t. So, and I guess I'll say that x2 equals s. So x1 equals negative s minus t. x2 equals s. x3 equals t. So I think it becomes s negative 1, 1, 0 plus t negative 1, 0, 1. And so this is the basis. Okay, let's see. And then the dimension of W, I think it's one-dimensional. because I have two free variables here. Maybe it's two-dimensional. I'm going to say two-dimensional, actually. So I wasn't sure on that one. I might as well screenshot it so that I can review it later. Okay, give me a solution to Q1. Rank nullity theorem application. So anyways, going to number 2 now. What is the dimension of the null space of A? The null space of A. 3. Dimension of the image of A. That's the output of A. I think 2 and 2. I hope this is right. Is the 0 vector in there? Yep, I was right. Okay. Oh, they used u and v. That's more common. That's right. Instead of x and y. So u plus 1 plus u2 plus u3 equals 0. v1 plus v2 plus v3. So u plus v1, u plus v2, u plus v3 equals that equals 0. Yep, it's closed under addition. And yep, it's closed under scalar multiplication. I need to actually write this out. So c, u1, u2, u3. Yep. Find a basis for w. Man, it's moving. Slow as molasses. All right, let's go to number 3. And I got a screenshot too as well because I wasn't sure. I was kind of just willy-nilly guessing. But I said that the null space was 3 because the rank is 2 and there are 5 columns. So there are 5 sort of variables here. So 3 of the variables have to be free variables. The dimension of the image of A. That's the output. I think it's 2. And pivot column. Anyways, I'm hoping that's right. I think it is. Linear transformation properties. We're going from 4D space to 3-dimensional space, where the transformation is equal to is this. We have a 3x4 matrix with rank 2. Oh boy, now we get this. This is where it's going to be tough. Is T 1 to 1? Is T 1 to 1? So in order to be 1 to 1, so we have a 3x4 matrix with rank 2. So I'm just going to write some notes about A. A, rank equals 2. Nullity equals 2 as well. I think that it's not 1 to 1. Question 3, I definitely need to review. This seems like it's not that complicated if I understood the last lesson, but I'm not understanding it fully. By the way, let's look at all this. Was this right for number 1? Yeah, I nailed number 1. This is great. At first, I didn't know what to do, but then I got it right. So to find the basis, I did all that. x2 equals s, x3 equals t. Let's go. And the dimension was 2. Nice. All right. Now, write solutions 2 and 3. I feel better about 4, but 3 is tough. Rank is 2, nullity is 2. I know the image has to do with being onto. It's about the range. It's about the outputs. And the kernel is about the null space. So I think that C is 2. And I think that D would probably also be 2 because it's rank 2. And then I'm guessing that it's no and no. That's my guess. I need to prove that better though. Meanwhile, I'm going to 4. They're still generating the answer I can see down here. So matrix of transformation. We want to go 3 dimensions to 2 dimensions. This linear transformation defined by that. The whole concept of linear is really important here, and I'm not sure I fully grasp it. So that's something I need to stay attentive of. Let's see here. Number 4. All right. So I have this matrix 1, 2, 3, 0, 1, 1. Let's get this into reduced row echelon. So I'm going to do R1. I missed the test when it was just Gaussian elimination. That first test was pretty nice, especially compared to this unit. So R1 becomes R1 minus 2R2. So I get 1, 0, 1. So the new matrix is going to go 1, 0, 1, 0, 1, 1. They want me to find the rank of A. The rank is 2. That's A. The basis for the null space. Okay, so the basis for the null space, I think to find the basis, I'm going to go x1 plus x3. I'm going to say x3 equals t, by the way. That's the free variable. x1 plus x3 equals 0, and x2 plus x3 equals 0. So therefore I get that x1 equals x3 equals t, and negative 2 equals negative x3 equals negative t. So the basis, therefore, is going to be, I'm a little bit just solving these from memory rather than fully understanding the why of each step. So keep that in mind. I think that's actually kind of more common than people will admit when you're taking a math class for the first time. If you've tutored math as much as I have, you realize that every subsequent level of math, going from pre-algebra to algebra 1 to algebra 2 to pre-calculus to calculus A, B to calculus B, C, or whatever you call it, calc 1, calc 2, that you always start with some review. There's always some algebra review. There's always some review of other things. You only really get math and make connections by reviewing it over, years, really, or at least several spaced intervals. So it's okay that I'm sort of just going through the motions to a degree here. By going through the motions, eventually it does click, and little connections just happen in your diffuse mode of learning. So looking at this here, let's see. x1, wait, why did I write x1 equals? I don't want that. Oh, whoops. So it's going to be negative 1, negative 1, 1. C. Now give a solution to number 4. I'm going to look at number 2 and 3 quickly. So number 2, what is the dimension of, going up here, the null dimension of the null space is 3. Yeah, rank nullity theorem, 3. What's the dimension of the image? The image is the column space. It's the rank. Yep, good. How many pivot columns? Yeah, good. I got number 2 right. Let's go. Okay, is T 1 to 1? No. Low-key, I'm getting all these right. This is funny. Good guesses. I got kernel and image dimensions. That's cool. But why is it 1 to 1? Why is it not 1 to 1? Because the rank is 2. The rank has to be equal to the number of input variables. I can't have free variables. So the kernel of T is not equal to the 0 vector. Yeah. Is it onto? No, because the codomain is R3, but the image has dimension 2. The image is contained in R3, but not equal to R3. It has to cover that whole 3D space, but it's only 2 dimensions though. Yo, I kind of get those. Okay. So with that in mind, let's try for C and D. Maybe I'm cocky on this test, but I feel like I'm going to do well. I'm going to ask it to make the test hard. I'm going to make sure that my prompt clarifies that this is a hard test. So let's see here. Matrix 2 transformation. Oh wait, I was just looking at the answer. What is the question? I want to finish the question first. Is it 1 to 1? So if it's 1 to 1, I think it's no and no still, because if it were 1 to 1, then that would mean that, well, let's see what they say. Oh, it's not 1 to 1 because the null space is non-trivial. There is a null space, basically. Yep. It is R2 because the image is two-dimensional. The image spans R2. I got this right. The basis for the null space. I got the rank right. All right, I'm ready to go. I'm ready for the test. Maybe I'm not. Maybe I'm falsely confident in getting false fluency by just reading through all the answers, pretending like I came up with them myself. So this was the 9-day unit that I just finished. They said 9 days. Let's see. This is next one's supposed to be 6 days. It's only 4 lessons though, which is cool. Major test. I'm just looking ahead because I'm always curious. These look like they're new things in each lesson at least. This unit had some sort of duplicate lessons, and I think it was really backloaded with info. The last lesson, I think I said this before, was harder than all of the previous 5 lessons combined in terms of being info dense and putting new material that they didn't prime me for in the first unit. And then this next final unit right here, symmetric matrices, diagonalization, eigenbases, eigenvalues, eigenvectors. Yeah, this is again sort of looking like each part is separate. Now let's go here. I want to say I'm ready for this test. Make sure it's appropriately difficult for an MIT level linear algebra class. All right, Godspeed. Here we go. By the way, this was yes. D was no. Oh wait, it's the other way around. This was yes. This was no. And it's because free variables. And yes, because 2D covers all 2D. All right. Dun 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 dun. Why is it called? I think the stream is misnamed. Settings, update all titles. Thought I updated all titles. All right. Unit 2 test is here. Give, oh God, precise definitions for each of the following. I hate this definition stuff. And then give an example that satisfies each one that fails with explanation. So, and then true or false, and some computation. They go for a 3x4 matrix here. Good to skim a test before you just dive in. Subspace geometry. Show that it's a subspace, find the basis, find the dimension. Is it the kernel of a matrix? If so, construct such a matrix. Dang, they made this harder. They just made all the matrices more annoying. No more neat 2x2 or 3x3 matrices. Now they all got like 4 dimensions. That's how they're making it harder, I guess. So is that what MIT does for linear algebra? Maybe. Not sure. So give precise definitions for each of the following. So 1A. Subspace of Rn region within Rn that passes through origin allows for vector addition and allows for, I don't know if it's allows for is a proper terminology way of speaking. Here, I want to check something. I'm a little annoyed that I think my stream is called the wrong thing. What's the site I called again? I'm such a noob here. I can go to YouTube. View my channel. Oh, okay, they have test number 2 there. Twitch, that's what it's called. Channel. Okay, they have the right name here. My channel. Claim your games. I don't want to do any of that. Twitch is such overstimulation, similar to TikTok. I like that I'm reaching people on these platforms, but it's really not for me. I feel I could get into it. I just have to retweak my brain, I feel like, to handle that hyperstimulation and not have it sort of get uncomfortable. I'm trying to not do that, though. I don't think it's healthy for our little monkey brains. So this allows for scalar multiplication. Whoops. I don't want this Gemini tab. I can just close Gemini here. Okay, a linearly independent set of vectors. Independent vectors do not contain one another and only have the trivial. There's a lot I could say about this. I feel like I know these pretty well. Solution to a x vector equals 0 vector. The basis for a vector space. Basis for a vector space describes region where vectors are linearly independent and span the whole space. All right, linear transformation. This is tough. Linear transformation by rotating, scaling, shearing. What's the other one? Or otherwise all right, and then a null space of a matrix. Null space it's such an interesting type of math where that you have to write definitions on the test as the first thing. It's like, but again, vocabulary is key in linear algebra, I'm seeing. So the null space of a matrix is the region that collapses it to 0. The 0 vector. Which I'm going to mention some rank nullity here is that which has the same dimension. I'm going to erase some of this. as the nullity or number of free variables. Okay. I'm going to go and submit this here. All right. Screenshot. Boom. 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 Then here, grade the first problem. Don't be too easy of a grader. All right, problem number 2, true or false? Two. Every linearly independent set in R3 has exactly 3 vectors. False. Oh, I didn't give the examples for each of them. Crap. I'll probably take some points off for one. That's what you get for not reading the directions. That's all right, though. Problem number 2. False. You can have 2 linearly independent and one that's linearly independent. That's linearly dependent. If I were putting more brain power into this, I guess I could come up with an example, a counterexample. I'm not going to do that. I want to move through this test too quickly. I'm a little impatient. The span of 3 vectors in 2D space is always 2. False. The 3 vectors could be linearly dependent. I guess I'll write an example. 1, 2, 2, 4, 3, 6. If A is an element of an m by n set of real numbers, and the rank of A equals n, the number, means that it's a full list, then AX equals B is consistent for every B vector. Yes. True. It is full rank. If rank of A equals n. I'm just curious what I got on problem 1. Yikes, 33 out of 50. I should give examples. I'm going to just quickly try doing that. I don't want to flunk this test. That'd be a little embarrassing. With the whole world watching, I flunked the test. Okay, so checkpoint quiz. I'm not going to look at which ones I got points off for, but a subspace. So EX. I'll say that I honestly don't really know how to give these specific examples because I haven't learned the syntax well enough. I hate how the downloads overlaps with this. Checkpoint quiz. All right. Maybe I won't give an example. I'll do that at the end if I have time. But I don't want to cheat by looking ahead and having it grade it first. So, problem 2. All right. This test way harder than the first one. If you're just tuning in right now, I'm getting rocked a little bit. I just peaked at my grade. I got a 33 out of 50 on the first problem with definitions. Though that was the hardest section for me last time too. I don't know how they got 50 points out of all that whole thing. I guess they were asking for a lot of examples and stuff too. So 2C. Oh yeah. The vectors can be transformed to become any other vector in I'm just going to say RM. All right, 2D. Am I supposed to give for each justify your answer with proof? Okay, true or false? Every linear transformation T with the kernel of T equals 0 is onto. I think this is true. I'm not sure though. I'm really not sure. I might be confusing this with one-to-one. I'm not going to go open note and look above. That would help me. True. This is the definition of onto, because there is no null space. I think it's false. I'm going to change my whole vibe here. False. This is the definition of definition 1 2, 1, but a linear transformation can have full rank, but not the whole image. I don't think that's right exactly. So I need a counterexample image of geez, this is tough. I shouldn't have asked it to make a harder test. I looked better when I just had them give me a normal test and didn't ask for it to be extra hard. Oh boy. Okay. This is going to be rough. I hope this is great on a curve. Hey, Code Mars, thanks for tuning in. Always appreciate when people hop in the comments and say something. So this is a really hard test. Man, image, maybe it's not. Maybe this is normal linear algebra test, but I feel like a lot of students would not do well in this without open notes or some way of a teacher spoon feeding them information. Even if you knew this stuff. This is difficult. All right, sorry, I was getting ahead of myself. I'm on 2D still. Every linear transformation, yeah. It could be I don't know what to do on that one. I'm just going to ask it to grade number 2 now. This might be a learning experience, this second test. Oh, it will certainly be a learning experience. Yeah, no example or counterexample. That's why I got wrecked on all this. That's all right, though. All right. Hopefully the computation goes a little better. I did ask it to focus on computation when teaching me in my initial prompt. 3A. Okay, so I have to row reduce this matrix. One, two, three, four. 2, 4, 6, 8, 0, 0, 1, 1. So I'd say that R2 becomes R2 minus 2R1 to become 0, 0, 0, 0. So the new matrix is going to look like this. 1, 2, 3, 4, 0, 0, 0, 0, 0, 0, 1, 1. So I can just tell you right now, it's not going to be full rank. Dimension of the null space. So I have to figure out the rank and the nullity. I actually want to find the basis for the null space first, I think. I guess I should row reduce this further. I'll say R1 becomes R1 minus 3R3. Does that actually help anything? I don't know. That seems stupid. I'm going to not do that. This is fine. Everything is fine as the house burns down. It's intense. All right. So A equals let's see, 1, 2, 3, 4. I want to find the basis for the null space. I'm pretty sure the rank is 1, 2, 3. Rank is either 3 or... I'll know when I find the basis of the null space. But basically... Sorry, so erasing is getting tricky. I wish Notability is a little better for erasing. I probably should use a better app than Freeform for taking notes, but it works just fine. Poor man who blames his tools, as they say. So it's definitely at least, I'm going to say rank equals 2. And then B, nullity equals 2. I'll say null space dimension equals 2. It might be 3 and 1. I'm going to find out that when I do this. The basis for the null space. Basis for the null space, I have x1 plus 2x2 plus 3x3 4x4 equals 0. You know, it would have been easier actually if I reduced it a little further. Oh well. Let's see how this goes. And then I have x3 plus x4. So I think that I gotta say, I'll say x4 equals t, x2 equals s. I think that should be enough. So I think it is 2 and 2. So let's go and see now. I have x3 equals negative t. And then I have x1 equals negative 2s plus 3 negative t, sorry, minus 3 negative t minus 4t. I'm just subbing in that. Okay, this is going to be good. X of 1 equals negative 2s plus 3t minus 4t is going to be minus t. Okay, so now I write this s plus t, and then x1 is negative 2, negative 1. x2 is just 1, 0. x3 is, what is x3? x3 is, just negative 1, 0. And x4 is 0, 1. So the basis for the null space is negative 2, 1, 0, 0, comma, negative 1, 0, negative 1, 1. This one's definitely going better than the previous ones. What is the dimension of the image of A? Okay, dimension of the image of A is also going to equal 2. And E is the transformation T of X equals A of X 1 to 1 and or onto? No, not 1 to 1. Because free variables. Onto is another thing. I'm going to quickly check. I'm just curious. Oof. Got wrecked on 2C. All right. This is going to need to be graded on a curve. Guess I'll ask it to grade number 3 now. Oh wait, I was going to look at the onto stuff or think about that. So onto means that the kernel is not 0. I want to look at my notes. I'm going to scroll up to the concept quiz just because I'm getting rocked. I'm going to say no, not onto. I think it's 3D space because there are 3 rows, but let's see. All right, man, my head is spinning. I'm sweating. It's a bold call to wear a tie buttoned up on test day because the sweat starts coming through. This is tough. Problem number 4. Did I screenshot number 3 yet, by the way? Yeah, the kernel does not equal 0. That's why I think it's not onto. Need to understand kernel better for sure. Done. Delete screenshot. Oh boy. All right. Number 4. Okay. Man, they did what all honors math classes tend to do and made the test harder than all the practice problems here. Partially because me and my hubris with that prompt. So problem number 4. Show that W is a subspace of R4. Okay. So passes through origin. It's the first test. I will say 0 minus 0 plus 0 equals 0, and 0 equals 0 plus 0. Check. And this was from x1 minus 2, x2 plus x3 equals 0. And this was from x4 equals x2 plus x3. I'm amazed that ChatGPT can read my messy Apple Pencil handwriting, but that's cool. All right, we go down now, passes through the origin. Now we go addition. So I say u equals u1 and v equals v1, v2, v3. It's like that for vectors. So to show it's a subspace of 4-dimensional space. So I'm going to go, oh, I need a u4 here, u4. Sorry, my iPad skills are a little shaky. Not an iPad kid. So now what I want to do is prove that u vector sorry, that W of U vector plus V vector equals W of the U vector plus W of the V vector. So I do U plus V vector, which means I plug in U1 plus V1 minus 2 U2 plus V2 plus U3 plus V3 I have that. And then I also have, I think I don't need to say equals 0. I think I just want to prove that it's equal to all these added up. U1 minus 2U2 plus U3 plus V1 minus V2, V2 should be a 2 plus V3 and that's a check. Check. And the same is true for the other equation. It's a little tedious to write it all out, but basically U4 plus V4 equals U2 plus V2 plus U3 plus V3. All right, and then scalar multiplication is the last thing. Scalar multiplication. Oh boy. So for scalar multiplication, I'd say that I put C there. So I'd say W of C U vector equals CW of U vector. I'm just going to say check. Hopefully give me credit for this. I can tell it's going to work. It's just annoying to write out all the things. Find a basis for W. Now we're talking. A basis for W. Why isn't it letting me scroll down any further? If I like run out of space on this canvas? Maybe. Whoa. All right. Well, I can just go to the side. That was 4A. 4B. Let's see how I did at number 3, by the way. Curious. Yo, 50 out of 50, ya boy. Rallying. Let's freaking go. I'm still in a hole. Best viewers on streamboo.com. Remove the space at JQL. Well, thank you, belated individuality, BGiz, GJZS. I don't know what streamboo.com is. I feel like it sounds a little bit NSFW, if you know what I mean. Not safe for working through linear algebra. Maybe it's a legit site. I don't know. I'm cool with Twitch. I don't care that much about getting a ton of viewers. I mostly am doing this for myself. It's cool to learn stuff. It's cool to be held accountable. And it's cool to test the limits of AI. I remember when GPT-3 first came out, just going, wow, this changes so much. This is insane. And I want to continue to push the abilities of what people think you can do with these technologies. So let's see here. 4b. The basis for W. So basis. The basis for W is going to be, okay. We got some free variables. I know that much. We got 2 free variables probably. So I'm going to say x of 4 equals t. And let's say that x sub 3 equals s. Let's see how that works here. I hope I got this right. It's weird because there are 2 equations. I'm used to seeing 1 equation, but I think I can do this still. Maybe I should be writing this as a matrix. But basically, x1 will equal, well, first I should say that x2 equals s4 t minus s, x4 minus x3. So therefore, x1 is going to equal 2 t minus s. I'm running out of room on the side too here. 2 t minus s. Brain is booting up right now. 2 t minus s. Looking back at the equation, minus 2x2, I did that, plus x3. So plus s equals 0. Okay. Am I able to write this basis now? So the basis is going to be x1. Oh, I want to simplify this. 2t minus 2s plus s. So it's 2t minus s. It's going to be t two, x2 is 1, x3 is, I should start with s. I think I'm good with these basis ones, solving them though. But let's see, s, erase. So the s value for this one is -1 for x1. It's -1 for s2. It's 1 for s3 because s3 is s, and it's 0 for s4. So s plus t, these are vectors too. T is going to be 2 for x1, 1 for x2, 0, and 1. Okay, so the basis is going to be this. -1, -1, 1, 0, comma, 2, 1, 0, 1. Why is freeform running out of space? That's so annoying. It should be just an infinite scroll. I'd like it to be that. Okay. I'm going to screenshot for A and B separately, I think. And have it grade those. Grade for A, for B. Here's for A. Here's for B. I'm going to just start a new note. I got to go. Test number 2, part 2. For C. Man, this is a tough test. It's long, too. The other one was not nearly as long. 4C, because I'm already over an hour on this stream. It'll probably be closer to an hour and a half reviewing my test results and everything. 4C. What is the dimension of W? 4 by 2? 2 by 4? I think, because there are 2 rows, 2 equations, and 4 columns. Is W the kernel of a matrix? If so, construct such a matrix A. Oh boy, is it the kernel of a matrix? So that means is it something that collapses a matrix onto the 0 vector. So I guess I have to write this out. I'm guessing, this is my guess. 1, -2, 1, 0, 0. And then I have, the other one is going to be 0, 1, 1, -1, because I subtract x sub 4 from both sides here, and 0. I don't think this is actually the right way to do this. I don't think I put zeros there. I think what I actually want to do is get an augmented matrix. Anyways, I'm just going to say for 2D, for D, yes, it's the kernel. Man, these are tough. Let's just see what happens if I were to put this into row echelon. I'd go get this first row to be 1, and then I'll add 2 times the second row. So 0, add 2 times the second row, 3, add 2 times the second row, -2. Add 2 times the second row, 0. The zeros aren't going to change is the issue. Yeah, I don't know. I'm just going to erase that. They'll probably penalize me. Oops. All right. So let's look here. I'm just going to go to number 5. Maybe I should have said no, it's not, because it's not a square matrix or something. I don't understand fully what the kernel is. I know it's something like the null space. If it's the null space of another matrix, then yeah, I don't know how to find the inverse of that quickly enough. So linear transformation analysis, what is the dimension of the image? It's going to be 3. Is T 1 to 1? No. There is a null space. Nullity of 2. C. Can the image be all of our 3? Yes. I think. I don't think that's right, actually. Okay, last part, proof. I just want to wrap this up. Prove that this set is linearly dependent. V is contained in a 4-dimensional space with the subspace of dimension 2. You have 4 vectors that are elements of V. Wow, I have to prove that this is linearly dependent. Oh, that's not bad. 6a. Must dependent if in any subspace with less than 4 dimensions. B. Explain why any basis for V must contain exactly 2 vectors. The rank is equal to 2. And 2 are linearly dependent. This is a very lazy proof. Let's see how they grade me. Suppose that this third vector is not an element of the span of V1. Can V1, V3 be a basis? Yes. Oh, no. Sorry, no. No. No, because if it's not an element of the span, I'm going to say, instead of say it's, I'm going to say V1. If V3 is not an element of the span of V1, then they must not be linearly independent. I'm just going to submit this. YOLO. See how this goes. And I'll start reading through the explanation specifically for 1 and 2 where I got rocked. Okay, so let's look up here. Number 1. So I said a basis describes a region where vectors are linearly independent and span this whole space. I got the essential definition, span and independence. The phrase describes a region is vague and more geometric than precise, and I'm missing concrete examples. So a basis for the vector space is a set of linearly independent vectors that span the space. Example 1001 is a basis, but 2 copies of 10. Okay, I could have done that. That's too easy. Ugh, all right, I'm screenshotting that. Subspace, a region that passes through the origin, allows vector addition and scalar multiplication. I mentioned the key properties, closure under operations, that's the keyword. I need subset, really? Doesn't provide a specific example. Yeah, I didn't do the examples, I was lazy. A subspace of n-dimensional space is a subset that contains the 0 vector and is closed under vector addition and scalar multiplication. Whew! This was a test that would have been hard to finish in an hour. I know I started with the concept quiz and I've been narrating my thoughts while taking it, but man, this is tough. So what I wrote, I need subset, I need a specific example. So an example is that, okay, an x vector exists in R2. I wanted to just like read that for me in plain English. English, mother flipper. Pulp Fiction quote. here. Still generating the answer. That's cool. So it doesn't provide a specific example or a failing example, so not a subspace. X2 equals 2x1. Doesn't pass through the origin. That's the easiest way to do it. Linearly independent set. Vectors that do not contain another, no, only a trivial solution. I hit the core definition by the trivial solution. I use the correct notation. Do not contain one another is vain. Language, no example or counterexample. A set of vectors is linearly independent if the only solution to that is all equals 0. So 1, 0, 0, 1. I need that. Okay. Screenshotting that for sure. One is a multiple of the other. I could have gotten that example. I need the constant to equal 0. Yeah, I remember that now. I'm going to screenshot this too. These are all good critiques on my defining things, honestly. Man, asking it to be a stickler on that definition section in particular was digging myself a grave right off the bat. That was really intense. So the linear transformation, geometric intuition. Yeah, I define things geometrically. I'm a visual mathematician, I guess. Missing the two defining properties of linearity, which is that u plus v equals tu tv, and oh, okay. This would not preserve addition. That's a tricky one. Man, these are tough. Null space. What I wrote, the set that collapses to 0 under matrix transformation. I got the geometric and algebraic idea. Collapses to 0. Dimension is the nullity. Could be more formal and clear. The null space of a matrix is the set. I'm going to ask it to do. Whoops. I ask it to read each of these into plain English. Oh, whoops. Oh, let's see my overall. Okay, 86%. I got rocked on 6B, but I did well on the rest. Oh, this is just on 4 through 6. So let's just tally up my score here. I have 69. Maybe I'll write it here. 69 plus the set of vectors x in two-dimensional real space such that the second component equals 2 times the first component. This is definitely worth saving. This whole thing is good, honestly. The null space of a matrix is the set of all vectors x in Rn. This isn't reading it aloud. Whatever. What was my overall grade on the? What was my overall score on the test? It's a bit deflated because I didn't give examples for the first one. Going back up. Every linearly independent set has 3 vectors. So I wrote that the null space collapses it onto 0, has dimension equal to number of free variables. So the null space of this set 1, 1 is t negative t. Solutions to this where b is not, the b vector is not equal to 0. Okay. That's worth saving. It's a bit tricky, but I guess I could have gotten better on that. Good intuition, identified correct core concepts in most parts, solid understanding of null space. Here's my overall feedback. More precise mathematical definitions. So precise mathematical definitions, reading the directions, clear formal language. So precise mathematical definitions and formal language. No, I don't want that. I just wanted it to grade it. All right. Yeah, it's false. You can have 3 linearly independent variable vectors and one that's linearly dependent. Your answer is correct, but your explanation could be clearer. You got the idea, but you didn't explain why. I gave a tangential example rather than a counterexample that directly refutes. The original claim is too strong. You can definitely have a linearly independent set in R3 with 1 or 2 vectors. That's what I was thinking at first. Ugh, all right, that's annoying. I should have gotten that right. A span of 3 vectors in 2-dimensional space is always 2-dimensional space. I said false because they're linearly dependent. Their span is just a line. I got a good counterexample. Okay. Okay, this one I got rocked. I wrote true and gave the logic that the rank equals n and this is full column rank. Tells us A is 1 to 1. We're being asked if the system is consistent for every B vector. That's a question about onto. This is a great learning moment, even though your answer is incorrect. So the rank of n means it's full. That tells us it's 1 to 1. I get that. But we were being asked if it is consistent for every B. Mapping onto that's a question about onto. Yeah, I need to understand this better. Screenshotting that for sure. Did this one well. Every linear transformation with the kernel T is onto. 1 to 1 does not equal onto unless the domain and codomain have the same dimension. Here they do, but you're sorted to say injectivity doesn't imply surjectivity. Okay. Problem 3, I got this all right. Not because free variables, it doesn't cover R3. Image is 2D. Yep, I was right. Good. And then showing that W is a subspace. Show that the 0 vector satisfies both equations, closure under vector addition, and closure under scalar multiplication. I did that all well. And then I used symbols like this in a way that's consistent with vector construction. Nice job. Yeah, I got better as we went. Find a basis for W. Did that right too. So that was great. What is the dimension of W? The dimension of W is 2. Yeah, 2 in 4-dimensional space, but it's, okay. Dimension is 2. Is it the kernel of a matrix? I wrote yes. You what? I got this one right? The matrix exactly encodes the constraints that these equal 0. Wow, amazing that I got that right. That was total BSing. I don't know if I agree with that grading. I guess I was getting rocked earlier, so it's nice that they threw me a bone. Linear transformation properties. Linear transformation properties here. 2 dimensions for the kernel. What is the dimension of the image? 3. Yep. Is it 1 to 1? No, there's a nullity of 2. Good. Can the image of T be all of R3? Or yes, the kernel is 0. I said the kernel has dimension 2. So yes, it is on 2. I need to understand on 2 better. Because rank equals 3. With rank 3, the image is... So yes, the transformation is on 2 even though it's not 1-to-1. 4 vectors in a 2D space of R4 must be dependent. Yeah. I got this right. So, yeah, the pigeonhole principle for linear algebra, you can't have more linearly independent vectors than the dimension of the space they lie in. Yeah. 2 are linearly dependent. This is not necessarily true. 2 vectors can be linearly independent in a 2D space. Yeah, obviously. They can be dependent or independent. We need more info. That's so annoying. Let me see what 6 was saying. The major test. Number 6, explain why any basis must contain exactly 2 vectors. That's so annoying. Can this be a basis? I said yes if this is true. They form a basis. I think I said no. Well, it graded this one wrong because I was saying the opposite, but I'm going to go with their grade. What was their overall grade here? 84%. Yo, what? B plus? Wow, okay. So 84%. I'll take it, I guess. They misgraded some of the things. Overall, I think it was balanced out. I definitely don't understand that last question. So I need more explanations for 6. Actually, I'll just ask it now. Explain 6A through C more. Oh, man. All right, I'm just stretching here. Let me go and do my thumbnail for this. You know what? We're going to get a prop. We're getting fancy here. Find a Sharpie or something to write with. Just remember I have this Sharpie. All right, pink Sharpie works. I'm going to go. All right, thumbnail is set. Let's see what it says here. Prove that it's linearly dependent. Yeah. Always dependent of set size. Yep. What is special about the number of vectors in a basis? It means that they're linearly independent and they span the entire space. If the dimension of V equals 2, every basis must contain exactly 2 vectors. Because the dimension of V is 2, the basis always contains exactly that many linearly independent vectors. I feel like my answer was actually more than 4 out of 10 for that. But this one I totally got wrong. Yes, because v1 and v2 are linearly independent and both lie in a 2D space, so they span V and form a basis. All right, I think I more or less get that. Today was intense, but it was a good test of how far I've come, how far I have yet to go. Definitely have to improve my formal writing. I forget how they phrased it exactly because I liked that. Formal definitions and this communication structure. Basically, I don't have the lingo fully down for linear algebra. But I'm getting there. We're making progress. I'm going to see here. Where was this? Oh God, I went way too far back. I liked the feedback here. I need to improve precise mathematical definitions and clear formal language. So I'll work on that. Thanks for tuning in. I'll be back tomorrow. We're starting Unit 3, where I think we're getting into orthogonality, orthogonal stuff, whatever that means, and tearing through the final part of this course. We're on to the second half. So thanks for tuning in. If you watched this and you want to keep following me on this journey, I really appreciate everyone who follows, everyone who subscribes, whatever platform you're looking at. It's really cool to me and really surreal that anyone wants to check this out. But you can learn stuff through AI by following this. I think it should be a good tutorial on how to learn with AI and how you can really learn anything. I mean, if a guy who hasn't taken a math class in 15 years, can learn linear algebra, there's nothing stopping you from learning whatever you want. You'll see some limitations that we're all running into, but overall, it's been good. So I'll catch you guys next time. Till tomorrow. Peace.